Let's talk about constructing a server-side template injection. Identifying server-side template injection vulnerabilities and crafting a successful attack typically involves this high-level process. It starts from detect, then identify, exploit, read, explore, and attack. Let's talk about the detect part. Detect part. Server-side template injection vulnerabilities often go unnoticed, not because as they are complex, not because they are only really apparent to auditors who are explicitly looking for them. If you are able to detect that a vulnerability is present, it can be surprisingly easy to exploit it. This is especially true in unsandboxed environments. As with any vulnerability, the first step towards exploitation is being able to find it. Perhaps the simplest initial approach is to try fusing the template by detecting the sequences of special characters commonly used in template expressions, such as the symbols of percentage, apostrophe, or brackets. If an expression is raised, this indicates that the injected template syntax is potentially being interpreted by the server in some way. This is one sign that the vulnerability to server-side template injection may exist. Server-side template injection vulnerabilities occur in two distinct contexts, each of which requires its own detection method. Regardless of the results of your fusing attempts, it's important to also try the following context-specific approaches. If fusing was inconclusive, a vulnerability may still reveal itself using one of these approaches. Even if fusing did suggest a complete a template injection vulnerability, you still need to identify its contexts in order to exploit it. Most template languages allow you to freely input content either by using HTML tags directly or by using the template's native syntax, which will be rendered to HTML on the backend before the HTTP response is sent. For example, in the free marker in the line hello Carlos, hello plus username, you will render to something like hello Carlos. This can sometimes be exploited for XSS and in fact often mistaken for a simple XSS vulnerability. However, by setting mathematical operations as the value of the parameter, we can test whether this is also potential entry point for a server-side template injection. Here, the second part is identify. Once you have detected the template injection potential, the next step is to identify the template engine. Also, there are a huge number of templating languages. Many of them use very similar syntax that is specifically chosen not to clash with HTML characters. As a result, it can be relatively simple to create probing payloads to test which template engine is being used. Simply submitting invalid syntax is often enough because the resulting error message will tell you exactly what the template engine is and sometimes even which version. Otherwise, you will need to manually test different language-specific payloads to study how they are interpreted by the template engine. Using a process of elimination based on which syntax appears to be valid or invalid, you can narrow down the options quicker than you might think. A common way of doing this is to inject arbitrary mathematical operations using syntax from different template engines. You can then observe whether they are successfully evaluated. To help this process, you can use decision and similar to this. similar to this, you should be aware that the same payload can sometimes return a successful response in more than one template language. For example, a payload, mhm, a payload, this one returns 90. For example, this payload returns 49 in Twig, uh, in Ginger it returns 7 sevens. Therefore, it's important not to jump to conclusions based on a single successful response. In exploit part, after detecting that a potential vulnerability exists and successful identifying the template engine, you can begin trying to find ways to exploiting it. How to prevent server-side template injection vulnerabilities. The best way to prevent server-side template injection is to not allow any users to modify or submit new templates. However, this is sometimes unavoidable due to business requirements. One of the simplest ways to avoid introducing server-side template injection vulnerabilities is to always use a logic-less template engine, such as Mustache, unless absolutely necessary, separating the logic from presentation as much as possible can greatly reduce your exposure to the most dangerous template-based attacks. Another measure is it only execute users' code in a sandboxed environment where potentially dangerous modules and functions have been removed altogether. Unfortunately, sandboxing untrusted code is inherently difficult and prone to bypasses. Finally, another complementary approach is to accept the arbitrary code execution is all but inevitable and apply your own sandboxing by deploying your template environment in a locked down Docker container, for example.